Have you started? Okay, so what we're going to do now is try and find out how much water each of these sand samples can hold before it starts to leak out, and that sort of represents what would happen on the track, where you put a lot of water on the track and the water soaks through the surface and starts to drain away. Now, the amount of water that the sand will hold is partly down to the particle size of the sand, because it's held by surface tension within the sand as the water is coating the sand particles. So I would expect the coarser sand, which if you remember was sample 1, to hold less water than the very fine sand. So that's what we're going to test. So we're going to do that by tipping the sand into this pair of, well, it's a single sort of tight material. This could prove quite difficult to do without spilling it. This is now dry sand. We dried it in the oven. Okay, so we're going to weigh that. Now the scales were zeroed with the tights and the container on them there. So we've got 252 grams of sand dry weight. Okay, so we're making it of that, 252 grams. And then the idea is that we soak it in water so that it's absolutely completely soaked through. We will lose a little bit of sand through this material, and that will affect the accuracy of the results, but we're not going for absolute precise accuracy. We're just going for a general idea of how much the weight changes there. So it won't be absolutely precise. So we're not losing much sand there, but we are losing a bit. Okay, so as the sand soaks into that, we will of course have a certain amount of water also held in this material. Okay, we just let that drain, and that sample now should be fully saturated with water. What we can try and do now is empty the sand out, so we don't have to consider the weight of the material, the wet material, and just re-weigh the sand. I don't know how well that's going to work though. We may have to redo all this. We'll get some figures from it, but whether we'll necessarily get accurate figures depends how easily we can get the sand out, to be honest, without leaving any in there. Okay. Alright then, as we said, some of the sand has got left behind on the material, but not that much. And that now weighs 313 grams. That's wet weight. Okay. So we can repeat that now with sample 2. Okay. Okay, wet material, we just zero that. Put sample 1 over there. Sample 2, doing exactly the same way as we just did with sample 1. Okay. Alrighty, so I'll get that nicely soaked. Make sure all that water is soaked in well there. Again, we're losing some of the sand out of there, not that much though. Okay, so let's weigh sample 2. Possibly using a little bit more of that sand. We are of course mixing the samples to some extent slightly as well. Okay, some of the sand is still attached to that, not that much, but it will affect the accuracy slightly. That's now 275 grams. Okay, let's do the same with sample 3. Okay, we already have the weights for sample 3. So, dip the sand in as before. If we do this video properly, we'll probably have to make it slightly more exciting than this. We don't want to lose the audience. May already be too late. Okay, so same again. We just get that nicely soaked in there. Let the water run out. Okay. Whoops. Then interestingly, that's still dripping water. That's a bit longer than the other samples did. Okay, so that now weighs 288 grams. Okay, do you want to pause or do you want to keep filming while I work out the difference in weight?